Hello guys, so today we're doing LeetCode question 98, which is validate a binary search tree. The question is, given the root of a binary tree, determine if it is a valid binary search tree. A valid binary search tree is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtrees must also be binary search trees. So example 1, the root is 2 and it's got a left root of 1 and right node of 3. The output is true because the left one is smaller than the root and the right one is bigger than the root. Example 2, the root is 5 with a sub nodes, so left node of 1 with a right node of 4. Right node of 4 has a left node of 3 and a right node of 6. The output is false because this is because the root's node value is 5, but its right child is value 4, which is smaller than 5 and it's supposed to be bigger. So the way we're going to do this is we're going to do a standard depth first search, and we're pretty much checking that while we input a minimum and maximum value, and we run it on the left subtree, and we set the maximum value as the node, and on the right subtree we set the minimum value as the node, and the maximum value is infinity. So as long as it doesn't meet these parameters, then it will return true. So let me show you an example on the whiteboard. So let's use the second subtree for example. 5, 1, 4, 3, 6. So let's say 3 is here, 5, 1. Let's make this one bigger, 6 actually. And then let's go 3, 7. So this one will return false, as you can see, because 3 is smaller than 5 on the right subtree. But now let's use that as an example. So again, we do recursion. Let's say we input as a function the max value, which is infinite, and min value, which is minus infinity. Now we loop through the left subtree here and the right subtree here. Now when we loop through the left subtree, we set the root as the sorry, let's go back. So when we loop through the subtree, we set as the max value as the root, because we can't get bigger than that on the left subtree, and the min value as minus infinity, so it can be as small as infinitely small. So as we loop through the tree here, we see 1 is smaller and it's not bigger than root. So then we go to the next recursive. There's no left root, no right root, so we return true here as we loop through the left subtree. Then we go through the right subtree and we'll set the max as infinity, because it can be infinitely larger than the root, and we set the minimum as the root. And pretty much we only return false if the current root of the current node is either bigger than the max or smaller than the min. So let's go down to 6 here on the right subtree. Now we're at 6. 6 is not bigger than infinity and it's not smaller than 5, which is a root. So we proceed. We go down to the left node here, 3. Now 3 is not bigger than infinity, but it is smaller than 5, which is the root. So then we return false. And let me show you how to do this. Okay, let's write the code. So we create a function to do depth first search. We pass the root, pass a minimum and a maximum value, which we'll set later when we call the function. Then if there is no root, then we return true, because this cannot be either smaller or bigger than the max. Then if the root.val is smaller than or equal to the minimum, or the root.value is bigger than or equal to the maximum, then we return false. And then we have to recursively search the left subtree. So we pass the root to the left as the root, we pass the minimum as the minimum, and we set the root value as the maximum because it can't be bigger than that. Then we do that because we search the right subtree as well. We search the minimum value as the root value, because it can't be smaller than that, and the max value as the max value, which will pass later as infinity because it can be infinitely big. And we return true if both are true. Actually, it's quicker if we just return it like this. So if both are true here, we're having to set variables for them. Return true. If one is false, it will return false. Okay, and then here we execute a function. So we pass the root. We set the minimum as minus infinity and the maximum as infinity. And let's see if that passes. See, we're not returning anything here, so we return this. It should pass. Yep, let's submit. As you can see, this is the fast time complexity. This is a time complexity of on, as we only loop through the subtree. Worst case scenario, unless we return false, which will be less. And space complexity of O1, as we're not really storing any other variables. Thanks for watching.